4, using exponents to solve problems. Working example number 1, use formulas to solve problems. Write an exponential expression to solve each problem. So, question A, what is the surface area of a cube with a side length of 4 centimeters? So they've got one drawn here. 4 centimeters base, depth, and height. So, surface area of a cube, we can use a formula. And because a cube has 6 sides, or faces, we can multiply the area of one face times 6, where s is your side length. So, s squared by itself gives you the area of one face, s times s. Multiply it by 6 to get all 6 sides of your cube. So in this case, we can substitute our 4 centimeters for the s, and so that becomes 4 squared times 6. 4 squared is 4 times 4, or 16. And then 6 times 16 gives you a total of 96. So the surface area of this particular cube is 96 centimeters squared. Don't forget your units when you're answering your question. Now note, the centimeters has the exponent of 2 on it because we're multiplying, well, if you look at it, it's 4 centimeters times 4 centimeters for one surface area. So that's 4 times 4 is the 16 that we had here, but then centimeters times centimeters gives you centimeters squared. So that's where that comes from. And then we're just multiplying it by 6 to get the full cube. So let's look at B. Find the area of the square attached to the hypotenuse. So the hypotenuse, just a reminder, is a diagonal line that is opposite the 90-degree angle in a right angle triangle. So the missing side of the square is the hypotenuse of a right triangle. As shown here, this is a right triangle. It's got a 90-degree angle in it. So here we can use the Pythagorean relationship, where the formula is c squared equals a squared plus b squared. C squared is your hypotenuse. So that's the diagonal of your triangle, or is side C. A and B, these are called legs of your right triangle, and you can use A and B for either of them. It doesn't matter which is which as long as you're consistent. So in this case, we've gone with this 5 centimeter square. We're using that for this leg, so 5 squared instead of a squared. And then this leg here is 12 centimeters long for this 12 centimeter cube. So 12 is substituted for b, so that becomes 12 squared. So we can add these together. So 5 squared is 5 times 5, or 25. 12 squared is 144. So you can square them, then add them, and you'll end up with 169. So now we've got this equation, c squared equals 169. So in this case we're lucky and 169 is a perfect square. So it's easy to calculate the square root of it. So the formula for the area of a square is a equals s squared, we already know that. Length of one side of the square is c, so c squared equals s squared. The area of the square attached to the hypotenuse is, well, it happens to be c squared, so it's 169 centimeters squared. So rather than having to take the square root of this to figure out what c is, we're lucky because we're actually calculating the area of this square, which is that length c times c. Sorry. So it's c times c, which is just the c squared, or 169. Next example. The square has a circle inside of it. This is a very common question that you'll find probably on a PAT, for instance. The square has a side length of 20 centimeters. Find the area of the shaded region. Okay, so if the square has a side length of 20 centimeters, another key detail to look at is that the diameter of your circle is also that 20 centimeters. So if you need to know a radius, for instance, then you can just cut it in half, and it'll be 10 in this case. So method 1, calculate things in stages. So the area of the square So the full square is s squared. So that's 20 squared, or 20 times 20, 400 centimeters squared. Then you can calculate the area of your circle as the second step. Area of a circle is calculated pi, or 3.14, times the radius squared. So as I said, we knew that the diameter was 20, so the radius is half of that, so it's 10. So we're going to substitute 10 for r. So it's 3.14 for pi times 10 squared. So 10 times 10 is 100, so we can fill that in there. And then 3.14 times 100 will give you 314 centimeters squared. So we have the area of the square, we have the area of the circle. So now, to find out the area of just the shaded space, we're going to take the area of the square and subtract the area of the circle. And then that will just leave you these shaded corners. So, area of the square was 400. Area of the circle is 314. Subtract them, and you're left with 86. So the area of the shaded region is about 86 centimeters squared. Remember, this is area, so we're working with squared. Now you could do it in one step and create an equation something like this, that the shaded area is equal to area of the square minus the area of the circle. Area of a square is s squared. Area of the circle, we're subtracting it, is pi r squared. And we can lay it out in one equation. It's essentially the same thing, it's just looking at the big picture all at once, basically, rather than chunking it into pieces. So 20 squared we already knew was 400. And then the area of the circle, it was 3.14 times 100. That's 314. It gets you the same answer, so it's 86 again, 86 centimeters squared. Just a slightly different approach to it, not a huge difference. All right, next up is a show you know. Give it a go.